What's up, guys? Thank you very much for being on ELECTRECA. Now, let's talk a little bit about overload relay, okay? And to be specific, thermal overload, okay? Now, I have told them here, I have this gigantic one, which goes up to 32 amps, from 23 to 32 amps, and then we have also this one that starts from 9 to 13 amps. Now, this overload, it helps us to protect our drives, okay? And it protects overload current, okay? Mostly in our motors. And you've seen we couple them. You've seen in many ways we couple them on contactors like this one, okay? Because we use contactors to engage motor circuits, so we have to add an overload relay for protection, okay? And what the overload relay does is that when you start your motor and then for some reason it starts to draw higher current. Now for example, if your motor is going to be drawing 32 amps, okay, of current, and then all of a sudden it starts to draw more than that, this gadget here, it will switch off the circuit, okay? And normally the reason why your motor will do, draw much current, it's due to overcurrent. And what brings overcurrent? In most cases, if the motor is burning out, let me say if the varnish is wearing out, then the motor will get hot, and then burn the winding. Then there is also another thing. If the motor is coupled on the gear and then maybe the gear get malfunction, it will definitely burn the motor. How? If the motor stays in one place stationed and it's turned on, if it starts buzzing, it will draw more current. Because if it's not running freely, if a bearing have a problem, it will still draw more current because it is stationed. Now draw more current and then it will burn, okay? So I wanted us to to see and also to learn how this thing works, okay? So I want to talk all that while I've opened it, and then we are able to know how it helps us, okay? Okay, now this is how your overload looks like inside, okay? And let's see how it operates. Now you see we have a bimetallic strip in here, and you know what a bimetallic strip does. It changes its position if there is a change in temperature, okay? So for example, if it's cold, it will be in a certain position. If it gets hot, it will move from position A to position B. Now it will act as a switch, okay? So how this overload works is we have an element here. You see these copper bars that is coiled around the bimetallic strip, okay? So right here we have contacts here, okay? Right here we have contacts here. We have normally closed and normally open. Now normally closed, it's what we use always, okay? Then normally open, it's where you're gonna connect your trip light. So the control circuit goes through normally closed. So if this thing is operated, of course it will switch off normally closed and it will switch on normally open. Okay, now you have a bimetallic strip here that it has been insulated a little bit. These are heat resistant. This sleeve here, it's a heat resistant sleeve, and then they have put this coil here. It's an element. Now the rating of this element, it is maximum of 32 amps, okay? That's the rating of this element, maximum of 32 amps. Now if this motor, that drive that it's on this overload, if it draws more than 32 amps, this element here, it will get hot. It will really get hot, very hot. So if it gets very hot, then it will operate the metallic strip, because now the heat on the element will be transferred on the bimetallic strip. Okay, and now the bimetallic strip will change its position. Okay, and it will operate. It will operate. We have a switch here. Okay, this is a switch. You see this one. So the moment it bends, now it will move the switch. This one. Okay, so and once the switch is moved, it will open the normally closed contact, which in turn it will open the circuit. It will interrupt your circuit, and then your motor will be saved. Okay, normally what happens is this one is not automatic. It can't reset automatically, but after some time, when the element gets cold, you will have to come and press a reset button here, which will then push back the strip to go back in its position. Okay, so you have seen that the bimetallic strips they have been placed on this. You see this plastic stuff here, it's a switch. So the moment they will bend, and they all bend in the same direction. So it was done in such a way that because the motor is drawing, even if the draw was on 1, so the motor is drawing that current. So definitely all of them, they will get hot, but even if it is 1, it will still operate the switch. Okay, all right. Now you have got a sleeve, this sleeve here inside. The reason why you have a sleeve here, it was put there because you have to avoid false trip. Okay, because this is a copper bar, it's just an element, so which means that if the motor is working even under 32 amps, it will get hot, but that temperature is normal. Okay, so that's why they had to put a sleeve here such that they are able to regulate that temperature to make it normal. Because if you put it without a sleeve, every time it gets hot and then the temperature is hot enough to operate the bimetallic strip, it will not serve any purpose, because it will trip under the rating of the overload. Okay, please tell me if you've learned anything in this video. If you're wondering how the bimetallic strip type work, I've explained to you. So we have very many types of overload relay, whereby we have other types in electronic. Okay, but we'll talk about that in another video. But the bimetallic strip one, it's the cheapest and it's readily used. Okay, so thank you very much for watching. Once again, please don't forget to subscribe, like, and share. And I'm out.